Hi everyone, welcome back to another live stream at uh, Major League Hacking Twitch channel. And I guess you might have already seen what an amazing session is coming up. But before we start up, I can see a lot of folks here. If you want to just introduce yourself in the chat, where are you hacking from this weekend? Before I actually introduce you to speaker of the day, I can already see folks are already interested for the session. I guess someone has asked. The answer to this question is yes. She'll be here presenting, talking a lot more about her career, how she has excelled it. And I'm actually very happy because I'll just tell you a thing that she is my senior. We have graduated from the same college, so it just feels super happy. Okay, can see a lot of yes in the chat. Okay, to start out with, folks, we today will be having with us Vishakha Sadhwani. She has 7+ experience in DevOps and cloud. She's a dedicated technical architect working for Google Cloud Platform. And before working to Google, she has also worked as a DevOps engineer at AWS. And she's also a subject matter expert of IAC offering in cloud formation. So without wasting any more time, I'll just have Vishaka on the stage. Hi, Vishaka.
Hello. Thanks, Vinayak and team for having me here with you all today. And yeah, I could connect with Vinayak, and he told me that he was my junior, so it's a good thing, you connect with people and through such forums. So happy to meet such folks. And also, Vinayak told me stories about like his experience and my experience, and we kind of had a good chat about it. But Vinayak introduced me a bit, and I'm going to just add on it. And like every other session, it always starts with KYS, that is know your speaker, because only then you can connect with them. You can understand what's their journey like, and like why are they talking about this topic, right? Like what was their experience, what is their expertise, and how they can help you in this too. So if you're looking for DevOps related roles or DevOps related concepts, you are in the right state like session. And if you're not, like just it's going to be a very light, high level session. So feel free to add questions, feel free to engage during the session as well. So a little Vinay, do you want me to introduce myself? Like I
Yep,
know
please.
just
Please.
about what has been cooking so far and stuff. So, Vinayak rightly said, I'm a technical architect at Google Cloud. What my role is, it's a customer facing role. It's also called customer engineer. What I do is like I work with Google Cloud customers to build solutions on the platform using cloud services. So they might have various business requirements, various technical requirements. So what we do, we make them live. We help them to deploy that on our platform. Prior to that, I was with AWS. Again, it was in the DevOps field. I was mostly working towards support side to help customers to utilize, leverage these services that were on the deployment side. But going two steps back, my journey with DevOps is pretty like it's like a story because I never knew about DevOps. I wanted to be a developer. I started from same school as Vinayak BIT Durg from like Chhattisgarh. Then I came to US for my master's, and my first internship when I applied here in the US after my first year, it was I applied as a software developer intern because I was more into like I was like a Java coder, so I was always in looking or passionate towards building applications and developing. Even though I did not have a lot of coding background, but Java was my go-to coding. Programming language. So I used to just do all the lead code, all the hacker rank kind of things. I did my master's in University of Maryland, College Park, and that's where like I got my first internship. And when I got the job, it was named as software developer intern. So I was pretty ready, like all happier on like getting that first gig. And then when I entered, my manager, like because I had limited experience, and he just added me to a project that was more around like they were migrating, they were transitioning their platform, their application platform from on-prem to cloud. that's where my cloud journey began, because I was just, you know, it. I was dropped into this one place where I know nothing about cloud. I had zero idea on like how cloud computing works. I had like the general concepts about it, but then eventually when I started working on it, I got a bit of hands-on experience with my mentors. That's when I realized this is a field which is like frequently growing, and it's again top of the market. It's on demand. So for not only for like you guys who are like maybe just starting your journey, or like graduating in a few years, or wanted to get into the professional world, cloud is a a good field to look forward to. It's on demand. I know generative AI is the buzzword, but how DevOps fits into every part of this is very important. Like you need to understand what it does and how it can be useful. So that's a kind of a quick, summary of myself. Uh, when I Do you want me to get
Yep.
started, or what's next?
Yep. Just to put out some things clear, folks, if you will be having any queries when Vishaka will be presenting, you can just list them in the chat. We'll be taking up at the end of the sessions. This session, she'll be talking about DevOps, her experience, so we'll have a lot to learn about. I'll be there in the backstage checking on all the comments, all the questions which will be popping up. So if you will have any doubt, you can just let us know. Uh, and folks, this is the first time Vishaka is presenting digitally. She has been an amazing speaker offline, but this is her first digital experience. Show her the amazing love and have a good time, folks. I'll be on the backstage, and the stage will be all for Vishaka.
Great, thanks, Vinayak. And yeah, I'd say like for the not having any technical difficulties. So yeah, the internet, please be good to me. Getting started. The name of the session is Demystifying DevOps, but it's a good combination of the DevOps tools and services. And I'm going to walk you all through the agenda as well. We can keep the questions towards the end of the session, and I'm happy to take most of them as long as the time permits. But I want to cover as much as I can. But at the same time, I want to keep it high level. Don't want to overwhelm you with a lot of information. So I'll make sure that I'm taking quick rain check around like if everyone's following or not. So let's start with our agenda for today. Uh, Many of you like might already know about DevOps. Many of you might be new to this particular terminology. So I'm going to give you a quick again 30,000 view of what DevOps is, and then we will go through. One second, sorry. We'll go through like what's interesting about DevOps. It could be like, what you should look out for. Maybe it might not be the field of your interest after going through this session, but maybe you might start liking it. So that guy on the left side has the same expression, like just trying to evaluate how this session would look like. But yeah, I'm also going to touch around cloud computing. It's again high level, just under explaining the concepts there. And then now that generative AI is out, we have AI/ML, and it's a paradigm shift. It's like, the world before internet and after internet. It's like that. So how you can keep up with that technology, how you can make sure that, you're not lagging behind, and how DevOps comes into picture. So I'm going to walk you through around like the stuff that you can look for if you're an ML engineer or a like you're going for a research scientist role. Like having that understanding of DevOps is pretty useful for you as well. Last but not the least, we're going to talk about money making DevOps. So it's a field uh, which is a bit, not in the market. Software development has been the topmost, like for engineers, computer science engineers, like IT engineers to look forward to. But DevOps is something similar and plus an advanced level. So you get good, you have good openings which you're not even aware of. So the money making DevOps is basically that, and how you can invest your, journey in it. So I'm going to just walk you through like the key practices or like what you can do about it, right? How you can get into this field and what are the free resources. Like you don't have to invest money to learn this thing. There are a lot of plenty of YouTube videos, plenty of other resources that you should be aware of if you want to enter into this field. So without taking more time, let's jump right into the term DevOps. So the name itself, what is it? It's a practice. Basically, you are practicing something around software development. So dev and ops, those are two different fields where it's a combination of development and operations. So when you mix it, it's a practice where you kind of embed this practice into your application development lifecycle. So right from the stage when you have something you're planning to develop, planning to make it available for the end users, to the time when an end user looks at it or utilizes it or uses your service, right? So from planning to the end user enablement, that's the entire life cycle of DevOps, to be honest. So it's a combination of two roles. So if you are a developer already and you know about operation side of things, you're a gem. You know because you know the entire life cycle, and plus you know how to communicate with other teams around it. So there have been multiple challenges around application development lifecycle, like when various like teams are communicating, and then there are consistency issues, like you want to continuously make a certain feature available for your end users, but you don't have the right resources to make it available. So you need to constantly communicate with your operations team. DevOps kind of embeds this, like, a DevOps engineer is the medium between these two teams and try to make things like from the ideation stage to the delivery stage. So, they on the screen, if you can see, there are ideas like, when is it needed? So, for an example, you're creating an application of yours, maybe an e-commerce site, right? Now you have another feature addition to it, and it could be like, you want to have a recommendation system for your customers. So that's a new feature. It could be a bug fix as well. You want to fix something out there. Could be an enhancement of an existing feature. So yeah, that's the idea. That's the requirement. And that could be your own requirement, your business, like your company's requirement, or your user requirements. Requirements can like, go around different stages, like different stakeholders are there. Now you want to make sure that it goes into this like entire delivery cycle where users can see this as soon as possible, right? That's the end goal of it. So you want to deliver it quickly. So that's where a developer starts thinking of working on the idea, like they write code around it, they write the feature, and then how do they make it available to the end users? The operation teams comes in, or the DevOps teams comes in, and they take that application, place it on a certain infrastructure, and that infrastructure is made available to the end users globally, regionally, or like even locally. So that's the job of a DevOps. So they bring the ideas to market faster. They help the teams, the developer teams, to make it live, make it production ready. So I'm not going to go deeply into it because we have other kind of slides to give you a good visual idea of what it is. So this is the DevOps journey in a nutshell. From the left side, you can see there's development. This is where developers come in. They write code, they write the enhancement on like an existing feature, and then maybe there might be a bug fix that end user or an internal stakeholder detected for an application. And there is something called automation, and DevOps is all about automation, to be honest. It's all about how you can reduce manual intervention, how you can make things easy going, easy flowing. So as soon as a developer pushes the code, how it can go through the entire pipeline to be available to the end user. So this is where automation comes in. Like we will go through this in detail in the next slides, but automation is basically the binding factor. you're helping the developers to make features ready for testing, for debugging, for also for the end users, again making it to production. CI/CD is the term that we'll focus on a little bit, because after this slide, I'm going to show you there are two focus areas of DevOps, and that is of like utmost importance right now in this world, in this tech world, to be honest. So those two focus areas is something you need to make your mind around, like whether you want to go with focus area one or focus area two or both. So CI/CD is one of the focus area. It's continuous integrations and continuous delivery. Now, there is a kind of a confusion around what is it CD, continuous delivery, or is it continuous deployment? It is delivery, because we have another phase called deployment, and there's a difference between it. And I will go through it, but again, a high level overview is deployment is when you're making it to production. Delivery is when you're making it available for people to, uh, you know, get it into a staging stage or a testing stage into another environment where internal stakeholders or a set of users can test it before it is live. Because these applications could be like business critical, right? You cannot release a change, a code, or a new feature without testing it thoroughly internally, or without making sure that it's ready to serve the end users, right? So that delivery phase is something very crucial. And then comes deployment, where or where the teams have attested to it. They're like, yes, it's good to go. We have got the required number of approvals from like multiple reviewers who have the authority to do so. And so it's live now. You can see that feature when you search on the website, right? Now comes operations. Operations is like, now your code is ready, everyone is using, you are looking at like that's your e-commerce site has that recommendation feature available. Now there could be something around traffic. There might be a lot of traffic hitting that, and that might overwhelm your backend, and your feature might not be visible at all because of 404 errors, or like 500 errors because of your server is down. So some or the other thing can pop up, and this is when operations team, these are like operations team come in. What they do, it's like it's more of maintenance and monitoring. Operations is basically that, like you're monitoring what's the latency like, what's the throughput like, what's your traffic like, how many requests are hitting that particular feature or the website, and how do you want to scale on the back end so that it's always available to the end user. So this is again the DevOps journey from left to right. uh, it starts from development, goes till operations, and this is like it keeps going, it keeps flowing, like in a way that again there's a new development, or there's a bug fix, or there's an enhancement based on like maybe monitoring comes out, brings up some kind of a change that you need to deploy, so you come back to development, and this is like a cycle that goes on. So now we come to the part where DevOps can be scary, because I'll tell you one thing around it. When I joined, I told you like I joined this internship and I had zero idea about it. It was still an internship, right? I was still in that phase of learning and applying. When I landed my first job, I entered into like I joined in as a developer, but since I had experience around cloud because of my internship, I was moved. Literally, I was moved to a DevOps team because they were in need of more DevOps engineers, and it is scary, to be honest. It was difficult for me to get onboarded to it, and it's a real thing. I won't say it's all good, it's all green here. There were times when I felt like, why am I doing this? What is like, what is the use? Is it worth the money? Is it worth the compensation, or is it worth the stress? Uh, so I started contemplating around like, is DevOps good for me or not? It can be scary because when a DevOps engineer comes in, they need to know two things. Again, the development side of things, then the operations like monitoring, management, testing, everything. You need to be an all-rounder. So, and there can be complex systems. You're not just like, if you're working for a company, you might have like multiple applications going out. So you need to understand like, how do you get a hold of it and then try to do things according to your management. You need a lot of skills. You need to know a lot of open source tools or like even cloud services that uh, it shows that whenever there's an issue coming up, you are able to debug it or able to fix it because it's your job. uh, Troubleshooting times, yes, you need to be a little bit more hands-on with automation. Again, you need to have Linux skills or like shell scripting skills. Could be a bit more because now you are again getting into that field, so you need to have that kind of an expertise. They could be on call as well. So DevOps does have, like, few organizations does have on call duties where you have to be available 24/7 a week. And you don't have any life because you cannot go out, so you have to stick to your desk or hang around in your home and like make sure if there's a page or a trigger that comes out, and you have to get back to your laptop and fix it, right? So there can be multiple other things, and plus again multiple tools. Like you cannot just build an expertise of all these tools that's available in the market, right? So it can be scary. But and like the picture says, developers, start running around like whenever they get a feature, or start running whenever they see they're monitoring them. But DevOps, they're like, they're stuck because they're like, in that mud around what to do, what's next and stuff. So it can be scary, but there are things that you can do. It's again, it depends on your job, how it goes. But the cloud part of things, the cloud DevOps that has been introduced in the past, what, 10 years, 15 years, it's in the market. It has reduced the work of a DevOps engineer a lot because it's a managed platform, right? So we will go through that again, the perks of having a cloud platform or like perks of knowing cloud DevOps. But cloud has uh, given like a good kind of a platform to engineers to focus more on productivity, innovation, new like creation of new services rather than doing the uh, like basic things of like running like debugging and stuff like that. You still need to debug, but there are tools, there's services that does it for you. So why not use that? So now it's a bit less scary, I would say. Now, this is that one slide I wanted to go through because it might be a lot for few of you folks, but it can be like, uh, if you want to remember something, this picture is very apt. You should, if you can like just understand this picture, that's almost the whole DevOps life cycle. So it's a practice again, right? It's a practice of continuously, building, deploying, and delivering. So how it starts? It's these all tools are available. So GitHub, it's all there. It's all open source tools. They're also cloud based tools, like kind of a similar version, but it's more cloud based. So it starts with planning phase. Like, again, that one, if you guys remember, there was a slide where I started like the high level overview. There was the planning stage. The planning stage is basically gathering the requirements from various stakeholders, could be internal, could be external. Once the requirements are ready, the next stage is for the developers to work on it. Like if it's a feature that they want to do, the developers have to code, have to bring that particular functionality, that add that logic to that application. So they will write code, and it's a new feature. So they already have their application code. They added a new feature. They push it to a version control system. Now, version control system is what? It is basically a repository, right? Like where people can contribute, like can be multiple developers, right? In a team, there can be multiple developers taking care of different features or like collaborating. So GitHub, these are version control systems. So where you can push this code or collaborate or like review code. So there are like multiple features, I should say, use cases of having a version control system. But it's more of a collaboration forum. So the moment you push your code, that you add that functionality, and it also, you the reason you have a version control system, with the name itself, it has versions. So you have a current production version, you can have a development version, you can have a testing version. So it's the same code, but minor changes, right? Like maybe uh, the staging branch has like a certain different functionality that is being again in testing phase, and production might not have that. So it's again, you are isolating the environments through Git, through version control systems. uh, and then you push that code. I know there's a question, but I'm going to take that around the end so that I can make sure I have the flow going on. But I will make sure I answer that. Uh, with Git, you push your code. That's when your the developer's job is done. They have done added the logic. That triggers a build. That's a build server. So what build server does, it's like a machine where your application code is pushed, or you can say it gets triggered. That machine starts because of that push of a developer. And when it starts, it what it does, it compiles the code with, like, runtime requirements. It could be different libraries. It could need, like, some third party APIs. So it compiles the code and give you an end product as like a jar file or a tar file, an executable product. So Maven, Gradle, these are like all the bell tools. There are multiple other cloud related tools with AWS, Azure, and GCP. But this is like more on the open source, just to understand what's the use of it. When you understand the base of like why this particular uh, like tool exists, or what's the use case, or what's the problem it's solving, you can easily map these things to cloud, to what cloud offers. So just like base around, like, it's a build server, and it compiles the code and it gives you an executable file. Then comes the testing phase. Like, there should be a QA environment where the engineers, if it's a Java-based application, for instance, they would run Selenium, like they can use tools like Selenium to test. The have They might have multiple test cases to run through the code to make sure that whatever is the end goal, it complies to that. That functionality which is being added, it complies to that. So that's the testing phase. Then if you go back, it's like on the right side comes the deploy phase. So on the left side, it's again, it's continuous development and continuous, that's the continuous development part. And I know there was some comment around D with, development, delivery, and deployment. So yeah, D also stands with delivery, sorry, development, and it's on the left side where, uh, developers normally, whenever there is a change, they constantly push the code, and they can, constantly deliver. That's the continuous developer part. On the right side comes the delivery part. So when you are adding it to the pipeline, right? This is the whole pipeline, by the way. With plan, code, build, test comes deploy. So now you have tested it in environments like staging environment, test environments, UAT, they're like usability testing. Comes deployment when you actually put it to production. You have a set of servers, and you want to deploy it on those servers, right? So uh, how do you do that? Like, there are tools who orchestrate these servers. Like, there's a new deployment coming up. I want to orchestrate it into 5 machines, for instance. And those are the tools like Kubernetes, Docker, Ansible. These are the orchestrators that kind of helps you with deployment. Kubernetes, again, my favorite topic. It's another focus area altogether. So we might not go into that much detail today, but like, it's a very diverse area. And if you are interested in Kubernetes, you have a lot of scope. Again, with MLOps as well. So when once the code has been deployed, what deployment again means is like you have a bunch of machines, and that machines are serving live traffic. So you can have a load balancer routing traffic to these backend machines, and you're basically pushing your application code into those machines so that that website is available outside. Comes the monitor phase. That's the last one, that's the maintenance type. You keep an eye on everything, like we said earlier. It's you keep an eye on like how your application is performing, how users are uh, utilizing your service or the feature. What's the traffic like? Do you need to scale and stuff like that? And if you see the center one, that's integrate. So Jenkins is one of the open source tools. Jenkins does the continuous integration part. It's like as soon as the code is pushed to the repository, the Jenkins pipeline is triggered. And what that pipeline is, it's basically multiple steps like build, test, deploy, like all these steps in that pipeline. So it's an integration point, like it is integrating the developers work to the operations work, like both of them together. So let me give you again, this is what now, remember I told you guys, like there are two focus areas around DevOps. uh, and these are the two focus areas are CI/CD, and then there is containerization. And CI/CD is, again, like I said, it's continuous integration. And then there's continuous CD. D is for delivery slash deployment when I said that. So continuous integration is left side, like the plan, code, build, test phases. Basically focuses on merging code on a frequent basis. So developers like merge their code to a shared branch, and then like after the planning stage, the code phase, and then this triggers the build server, and then once the build has compiled the application code, it kind of goes for testing. So I'm not going to go into detail again because I don't want to bore you guys with that. On the right side is delivery. So when the package is ready, the end package, the build server, after running all the integration test or unit test on that code, gives you a package, and that application package will be custom to your application code. It could be dependent, like if it's Java, it would have a jar file. If it's other language, it would have that format file. So it's a package. That package is that package goes to the uh, staging environment. Now, continuous delivery is automation. Like, you're automating the steps around take pick like taking that application file and putting it into a staging or test environment. That is continuous delivery. So you don't really need a lot of approvals there. Like, if you are a developer, even you can do that. You can, the moment you push the code, the build and test phases gets over, the package is ready, and if the developers can have that code pushed to a development server or a staging server, and then they can test that. When I say getting it deployed to a deployment server or staging server, what it means is like if you have machines for production, like which is serving the live traffic, the end users for your retail application, you can also have internal machines for your internal testing, right? So you can have these servers focused only on, testing the code for developers. Only internal stakeholders have access to it. These servers are not external. Like there's no way this thing is available to the end customer. No one can come and there's a different URL altogether. That could be dev test your company's domain or your QA test your company's domain. So that's, again, these are backend servers. The URL is pointing to these servers, and that server is running your staging environment code or your testing environment code. So continuous delivery is that. When you go for deployment, it's basically making that uh, uh, once it has passed all these stages, like staging and QA as well, making extending it to production. So deployment comes when you're making it available to your uh, end users. Again, production is live. You will have these servers that you are pushing your code to are only for your external users, or maybe it has internal applications too. You guys have, but it's live. It's something that is accessible. So continuous deployment has that kind of a thing where you are uh, kind of extending that process from staging QA to production. Now, why is it different? Because it's almost the same. You are running in staging QA and you are going to production. One of the reasons it's different is because whatever you're running on staging QA doesn't need a lot of manual approvals, but production does. You need approvals from your higher ups or your, managers to approve that yes, this is good to go, and only then. Once they attest, that's when it goes to production. So you might need manual intervention. You might need to have an automation as well around that circle. So continuous deployment is more on like if you want to just make it simple. It's more on like when you are serving the end users, and that's when you are like continuously deploying for end users. Uh, the idea is having these few iterations, making changes more frequently, and making it available to the like the external users. That's the way DevOps culture work. They want developers to make small changes but frequent changes, right? Rather than sending a bulk of like maybe uh, you have one issue detected through your operations team, and have you have been, you did not fix that right away, and you're waiting for multiple issues to pile up before you can make that big change. That's not the approach that organizations follow these days. It's more of like if you detected an issue, make sure once you've debugged it, you find the root cause of it, you make change immediately, or you make it available or make it production ready immediately. So it's continuously, you're going through that cycle. So smaller changes, but make it frequent changes. This is an end-to-end application development platform. So for all of these stages within DevOps, you need tools. Like I said, there's Git for coding, then there's Maven Gradle for build, then you have again Selenium for testing, and then deployment wise, you have orchestrated tools. If you want to just have an idea on what's running now, like for this is a very basic architecture. Organizations have very complex architectures too, but this is like a pipeline. So it's like you have a software development lifecycle. This is DevOps lifecycle. With software development, you develop, and then you kind of like get the requirements, you design, architect, implement, and then maintain. With this, you're basically, it's again stages wise. You kind of push the code, you build, you package it into a certain format, you push it to a registry. And this registry comes into picture because of certain new technologies like containers, right? That's the second focus area, and that's right around the corner. So I'm going to go next right away. So this is like an end-to-end, again, just to give you a visual picture of it. Operate is, again, the run part is the servers. These are uh, like the backend on which your application runs. It could be a Kubernetes orchestrated server. It could be a serverless. Serverless is basically you don't have to manage the hardware. You just have to focus on your code. That's it. And operate is again maintenance, monitoring, constantly seeing like what's going on with your application, tracing like what's the journey of your request. Everything like that comes under the operate field. So, going forward, this is the containers part. So, one of the focus area is CI/CD. Second focus area is containers. Containers are knowledge of containerization is very, it's very on demand these days. It's every, if you know about containerization, the concepts or like the major big problem it's solving right now, you're ready for the interviews. At least you would, if there is a question around containerization, you can tackle that. So why it exists, like what was the need of having containers, right? So where containers come around the deployment phase. If you remember the CI/CD pipeline, there was a deployment phase. Containerization comes there, where you have packaged the code, and you want to package it in a way that it is efficient. It is giving your applications the enough resource to run in that server, right? So it started with shared machines when, like, if you go to the traditional times where there was a simple physical server. only one physical server where your application runs on the hardware itself. And that hardware has no isolation for, if you just visualize it, if you want, there's a server and you have two or three applications running on that hardware. There's no concept of isolations. Like, you cannot isolate one application from another one. People who have access to application one has access to application two. Plus, at times you don't know how to manage the resources. By resources, I meant CPU, memory, storage. Like, how do you separate it based on applications? So that was the traditional times. It was also called bare metal servers now, but these were the old times where there could applications used to run on the hardware level itself. Then came the generation of virtual machines. What it did was it emulated a whole computer environment, or computer system, I should say. When I say computer system, it is basically, again, CPU, memory, storage, disk space, and stuff like that. It kind of emulated that as a software called hypervisor. So what hypervisor did was it gave uh, a space for other applications to run on top of that hypervisor, but in that isolation that it requires. So application one would have its own CPU memory storage. Application two would have a same or different CPU memory storage. Whereas in shared machines, all these applications were using the CPU memory storage from the same hardware pool. With VMs, it became separate. You, like, application one would have 512, 512 cores of CPU, and it might be 256 for application two. So now you can, like, utilize the resources in an efficient way altogether. Again, step isolation doesn't, let one application communicate with the other in that easy way that shared VMs used to do. So it really helped with that. There were a few cons to it. Again, it was another hypervisor was on top of the machine's OS, right? So it added a management layer on top of it. Now, when there's management layer, there could be some performance bottlenecks, right? Because the management layer is also taking some CPU to run. So now the applications that were running on top of it, like the VMs, the mini VMs, you should see, if you want to look at the picture, there are like mini VMs running on the same server. It became like a bit performance wise, it was a bit less than the what shared machines used to offer, because you were running right on top of the OS with shared machines, but here you're running on top of hypervisor, so it's kind of like not giving you the best performance there. Now the last part is basically containers. Containers are, I should say, it's a way of packaging your application code with everything, with your runtime dependencies, with your like various modules that is needed by your application, whatever container, like whatever in like resources you need, like a third party APIs you want to connect. You're downloading it and packaging it all together into an image, and with that you create containers. So containers are like basically lightweight units, and it runs on a container engine. Sorry, did I move? Yeah, it runs on like a container engine. So what it does, it's like it gives you more isolation. Again, it's lightweight as compared to virtual machines. So virtual machines were still these mini VMs on a big VM, but these containers are mini application units that is again running on a single VM, but it is more efficient in terms of performance because there is no hypervisor that would take away your performance. But they is like these containers need a container engine such as Docker to run these containers on those VMs. So isolation wise, it did the check. Yes, it's good. It's good. Uh, no common libraries, so there were no kind of issues with dependencies, right? Like one application's dependency doesn't interact with the other, so it's good there. Less overhead. Again, management, there's no management layer, so you don't have to worry about it. And it is portable, like you can go around it, uh, just take that image and deploy it anywhere. You don't need to get into that VM, install everything, like all your runtime, your application specific runtime and everything. You can just use the image in on any VM. So it was very portable. So that was one of the biggest reasons why container came into picture. Now we've talked about DevOps a lot. It might be a bit overwhelming again. I don't want to dump a lot of information altogether. So maybe we switch topics to something called cloud computing. What does cloud computing mean? Is you are basically using servers on cloud, not like a private data center. Also, if you maybe I go back to containers because I wanted to give you that analogy. Let me go back 1 second. So yeah, with shared machines, if you want to memorize it in a way, or if you want to keep a hold of it whenever you're going out for interviews and stuff, with shared machines, consider it as a big house where everyone shares everything. With virtual machines, consider it as separate apartments in the same building. It has better privacy, but it utilizes the same resources. Like, they might have the same dish, washer, dryer unit, and stuff like that. So you kind of still share some resources. Uh, but if you go for containers, these are like tiny, efficient houses built on the same foundation, but have everything of its own. Like you're not sharing even the washer dryer with containers. So if you want to just keep it in your some part of your brain, that's how you can like visualize it. Uh, and that really helped me because when I used to go for interviews, I used to these questions are pretty relevant, like to know. Just to be respectful of everyone's time, I'm going to just quickly go into cloud computing in a nutshell. Uh, it's a platform altogether where when you have applications, you have, a need to make it available for everyone. There could be some issues around scalability. You want to make it globally available as well. Reliability wise, how many times, your service does the thing that it is meant to do, right? Uh, so there are a lot of things that cloud computing solves. It brings up a managed layer. So a lot of things that you had to do manually when you were working as a DevOps engineer, or as a developer, or as an operations or AI/ML engineer, for instance, it became a bit easier because of the managed layer. So, for instance, your retail site again, your application, it hit a lot of traffic, a lot of public started hitting that URL, and now all of a sudden it's down. Like you have an outage. The reason is because you don't have enough servers, or you did not bring in the right number of VMs. So scalability wise, when you depend on cloud computing, it's more managed. What it does is auto scales. It depends on like it monitors your traffic, and earlier you were running your application on 5 servers, but due to the peak traffic, it needed 10. When you were on your private data center, private, local data centers where you're running the application, and you're in cloud, it might automatically move it to 10 servers just to make sure it is available for the public. So scalability is a big, big thing for cloud computing. So it kind of reduces the manual intervention and add automation to it. And that's the main essence of it, automation. DevOps is a part of cloud. DevOps is it's not similar to cloud computing. DevOps is a practice. It's if I want to just give it in a sentence, it's a practice that you apply to your application delivery lifecycle. So now cloud computing have two things. One is the deployment model, another one is the service model. So just to get you guys a bit comfortable with cloud computing, let me show this. This picture is a good kind of an visualization around what it does. So when you say public cloud, public cloud is you can just see outside. It's the cloud. I don't know where everyone's joining us from, like from different time zones. You might not see the cloud right now, but cloud is basically you can access these services over internet. Like you don't need to be in a local network in order to access these services. So you can access storage. You can access like your application servers. You want to connect to your databases, all everything you can connect through internet. And that's basically cloud. Wherever you go, it follows, right? Internet, again, internet came in, so you can access things outside your local network, right? So that's how cloud computing is coming in. And what are the cloud providers? So, AWS, Azure, Alibaba, Google Cloud Platform, these are like the big cloud providers here. So if you want to have an analogy of it, consider it as a bus. So, people can use that, like multiple people can use that particular bus, right? So there could be multiple organizations using the same cloud, and it's available over internet. That's public cloud. Private cloud. So your company doesn't want to publish your data, or wants to keep things private to their data centers. What I meant by data centers is like, sorry, there is like, you manage your own servers, you maintain it operations wise. If there's any failure, you manage your own users, like only if there are 100 employees in that organization, only 50 of them who have privilege to have access to that. So that's a private data center. And it could be compared to as like your own car, your own BMW, Tesla, or whatever car you are running, but it's your own car. So you are not sharing it with anyone. So that's it. That's where you are running your application. Hybrid cloud, it's a mix of both. So you can have a bit of cloud, public clouds, or you can have your on-prem. Private cloud is also known as on-prem. So if you come across on-prem data centers and stuff like that, it's private cloud basically. You are managing like the entire, when I say private, you are managing the infrastructure costs around servers and like your hardware. You're managing the capital expenditure that is required to maintain it, to operate it at that scale. Hybrid cloud is, again, it's like a taxi. Anyone can utilize it. So it's a mix of public and private cloud. Few concepts that you should be aware of is, this is the service model. So now you heard about the deployment model. Cloud computing is basically divided into deployment and service model. Uh, when you go into the service model, pretty sure few of you have heard about uh, SaaS, PaaS, IaaS. Uh, On-premise is, again, private data center. So when you say on-premise, you manage everything, right from like networking, storage, like all these, like the full stack. I'd say, like, the whole stack of right from hardware to the end application. That's under your management. So you might have uh, operational requirements around it. You might need enough workforce to make sure these servers are placed in the right uh, stage. So I, I don't know, I heard a bit beep sound, but maybe it would be something kind of a timer. So I'm going to just quickly summarize this. So on-premise is your own managed data center. So you are responsible for everything, right from managing your servers to deploying your code, deploying your application code, right? Uh, so when you come with IaaS, it's called infrastructure as a service. What it does is it takes away a lot of management from your side. So networking, storage, uh, these like servers, virtualization, it's all taken away. It's being handled by another platform. Could be a cloud platform, could be another, like it could be anything, right? But when you say infrastructure as a service, you're just focusing on those top four things: application, data, runtime, middleware, and operating system. So when I say this, it gives you more power to make changes. So if you have a custom runtime for your application, you use IaaS, right? When you have a custom like OS requirements, which is like licensed Windows Server, licensed machines, then you use IaaS. When you go for platform as a service, all you need to make sure of, like, you need to manage is your application and data. That is it. You don't have to worry about what how your runtime is installed, how your middleware is working, what OS are you working on. That platform is already there for you. You just have to focus on developing the code and making sure your data is very well connected with your application, and your data, managing like the connections and communication around it. When you come to SaaS, it's the software as a service, right? It is like the entire thing is encapsulated and like covered by the platform itself. So you don't even have to manage around your, like, how your application is running. What you got to do is just focus on giving that package, like giving that file and running and deploying it on that platform. So the rest of it will be managed by the platform itself. So these concepts are good. There are multiple services. There's like blockchain as a service, like security as a service. So they came up with these service models to make sure that they can automate things for users, and they can like present a way where automation can help, and like less management, less overhead can help people to be more it basically gives people the power, or like the organizations the power to choose if you want to run only if you want to have like full control over your infrastructure, or if you just want to focus on your code. Like you're a developer, you're a startup firm, you don't need to manage everything, the operation side of it, the infrastructure side of it, right? uh, so that's it. Like depends on like how much control you want for your services, as well as like how much the other party manages for you. Cloud DevOps is uh, DevOps again. It's a practice. It's a set of things, set of steps, set of tasks, I should say, that you got to do in order to run this particular practice on cloud. That's cloud DevOps. So a lot of things that we saw around planning, coding, building phase, cloud helps you automate a lot of things. Like when, for instance, I'll give you a very simple example. So when you push a code, you go manually. If you have like open source toolings, or you have your own custom pipeline, you push your code. There's like a person has to go and trigger the pipeline so that it can pull the code into the build server, and then it would pull the dependency. You have to write a script for the build server in order to understand, in order to package it, like package the code into the jar file or tar file, right? So you have to write that script, and then you again manually a person has to go and deploy it in the staging environment, right? A lot of these things can be automated, right? Like the moment a developer pushes a code, there's a trigger in the cloud source repository that would immediately start the build server. The build server would have the code. It would compile it with the dependencies, and it would give you the uh, end package. And that package, if it's a container file, it's an image file, it goes to a repository where, again, there's a pipeline altogether, which would eventually it would also run all the tests for you. It will deploy it to the end server. So just imagine how much work it is, like, it has taken away from like the uh, people who were doing it manually, right? So one of the biggest benefits of using cloud is, you have a less overhead. You have like, you don't have to manage a lot of things. You don't have, as a DevOps engineer, like I said, as an on-call, I used to get up at like 2 a.m. to add more servers to my application because I noticed some uh, more traffic. So that thing now is being solved by cloud because I have a certain range of minimum and maximum servers that my application will require, and the cloud will manage it for me. I don't have to get up at 2 a.m. now and scale up. The management platform will do it for me. So all these things around scalability, availability, when you look into such platforms, you see how well it has flourished, and it is helping others. So again, cloud has embedded security. So a lot of times, uh, it the organizations miss, there are privacy concerns, there are data security concerns, there are data leaks. Uh, Users who should not have access to production servers have access to it. So there are a lot of security concerns with private data centers or on-prem cloud, right? Sorry, on-prem data centers. So that kind of things come pre-built with cloud. So you don't have to, like, there are a lot of best practices that you need to do. It's not like everything is managed by the uh, cloud platform or the people who are running the cloud platform. It's a shared responsibility model. So you apply the best practices. The management platform has the set of best practices embedded in it. So it's a combination of both. It's a shared responsibility model. So it's, again, security wise, it's much more secure. Frequent deployments, again, you set up the pipeline, things start the with the trigger, it starts building, and you might even see an automation around attestation from people to deploy to production. Benefits, we have already heard about it a lot, so I'm not going to repeat it. Now, maybe this could be something that might be of interest for AI/ML engineers, but the buzzword is out. AI/ML has been rising like anything, and a lot of practitioners have been creating models and trying to understand how these pipelines are set. So now there are three key areas with AI ML. I'm not an expert again. I'm more on like application modernization side, but there are three key areas that I've been able to figure out. It's uh they have con training. There's training. There is where practitioners are building training models like with a lot of data sets. They have like data processing pipelines and stuff where they're ingesting a lot of data to train these models. There is inference where basically you are serving those models to the end users like through APIs or through other applications like end applications. And there's again the third area is MLOps is how you are deploying these training and inference workloads. MLOps is uh, not exactly what DevOps is, but MLOps is a subset of DevOps as well. You could imagine like the pipelines that we have. Just imagine having those components for AI/ML. Like you have continuous integration whenever your new data is coming. There's data validation, there's data pre-processing, then there's data ingestion. Uh, then it's being fed to the models, and then there's continuously it's being delivered or deployed on these. The models are running on some servers, right? So it even those servers are like running these tasks around like cleaning, ingesting, and then training the models. And then there is these servers, if you see on the screen, that's the part of it. So everything like on the uh, top, these are like your AML models, like it could follow PyTorch, JAX, some kind of frameworks, right? But underlying, it is running on the compute cluster, right? So if you know about these compute clusters, GPU, TPUs, these are like the on-demand NVIDIA, why the stocks are, pricing right now. It's because GPUs, TPUs are of very much demand right now to run these models because they have like the high computing power to hold these models. But Kubernetes, K-natives, these are the concepts that is what we learned through DevOps. So if you know DevOps, you know a bit of it, and when you're going into interviews, it's where it will be helpful. So I see Vinayak, so I know my time is up. Uh, but maybe I'll take 1 minute because I really want to go through this, Vinayak, and I'll let everyone go. There
Sure.
are multiple roles around DevOps, solutions architect, developer operations, TAM. Uh, all of these roles are specific, and a lot of these are like not even being looked up. Because when I was searching for jobs, I was always aiming for software engineering roles or like associate roles around interns, uh, like development roles kind of stuff. But there are a lot of roles which are easy to grab, and even not, I won't say easy, but it's available, and like this not many people know about these roles. So if you're up in the job market, try exploring these roles as well. Where can you start? Three key advices that I want to give, just because we are summarizing it and we want to finish it. Be hands-on. Like like if you're learning cloud, there are multiple cloud credits available. There's a $300 credit with Google Cloud. There are Azure credits. Like Amazon provides some credits. Use those like credits to create your profile uh, in the cloud platform. Have access to these services free of cost. Again, you're not paying anything, and be hands-on. Try to test on like storage, databases, networking, compute. Like find your own passion there within the cloud world, because there are multiple specializations within. Certifications, they're like these not super into the services, but giving you high level overview of the services which is under cloud. Even like open source like HashiCorp, Terraform is good because if you want to learn infrastructure around like how you can automate stuff with DevOps. uh, These are the few certifications you should look into. And the third advice is just network and learn. Like, go to conferences, meet people. You might not know, like, you can, you find people who can share some ideas, insights around these fields. Not just DevOps, it's like for any other field. You're going into AI, ML, data science, just network, try to know people, try to understand, connect through LinkedIn, know about their, like, journey and how you can also plan something of your own. So that's a wrap. I know we don't have a lot of time, but I'll hand it over to Vinayak now.
Uh, uh, just for a reference, I guess we are almost over time. Uh, Thank you everyone for joining up. I know we had a lot of questions. The cases, okay, so everyone is asking, can they get a hint of slides?
Yes, I'll share it with it in the Discord channel.
Yep, that will be great. I see a lot of questions. Even if I ask everyone to put up uh, the insane amount of folks which are actually present in the stream right now, will be over 150 questions as per the folks which are here. So, but with that, folks, thank you so much for hopping in. Thank you so much, Vishaka, for sharing your time. One thing I can clearly say, throughout the stream, it was fully interactive. Everyone was constantly asking questions, and personally, me, learned a lot of things around DevWorks. I was there in the backstage, so this whole thing was super amazing. Do you want to end up by saying something?
No, that's it. Glad you guys, glad I could meet you all. Sorry if I couldn't take all the questions, but thank you for having me here. And I'm on LinkedIn if you want to connect and if I can help you with anything. But again, thank you for joining us today. Have a good rest of your day, night, and weekend.
Yep. Yes, folks. After this stream, your today in Global Hack stream will start immediately. So I and Vishaka will take a leave for now. You can connect with her on her LinkedIn. If you want to connect with me, you can connect me with on LinkedIn and my Twitter under the name of Vinayak Rawat. But with that, folks, we'll take a break and we'll see you soon.